politics, not because I wanted to do that, but because I felt this was how I could impact the climate emergency. It is the reason why I ran, and when I saw something on social media about Serena's project, I reached out. And I'm so moved by this work. It is important. What you guys do is important. In art history, what spoke to me the most were the pieces that were social justice, political commentary, and what people need to see and understand about the times we live in here is best conveyed through art. The storytelling that you do visually is critical. So I was so excited about this project. It's turned out beautifully. Richmond has extreme heat island issues here. So to me, for people to drive around and see this and maybe think about it in a way that they wouldn't understand if they saw the data, this is what art can do. So again, I'm thrilled to see it. Congratulations. And I also love the technical aspect of this, but that is your presentation, so I'll say it for you. Thank you.
Parents and family members who are here for family weekend. My name is Roberto Jamora, assistant professor at the VCU Art Foundation program. It's a privilege to be both an alumni and now a professor here at VCU Arts, an institution with a tradition of greatness in the arts. And today I'm absolutely thrilled to introduce Sirena Pearl, who is continuing that tradition. Last fall, Sirena was a student in my surface research class, which if you're not sure what that means, it's basically a 2D design fundamentals class that focuses on color theory as well. And in my class, she was always challenging my project prompts, which is good, in terms of both ambition and scale. For example, creating a 4x5 foot glow-in-the-dark painting in 2 weeks for her final film project, which was really awesome. And this past January, after Sirena got a total A+ in my class, Sirena requested to meet me over office hours to discuss a truly interdisciplinary project. A project that draws from and integrates several bodies of knowledge, including the visual arts and the environmental sciences. She came prepared with the academic literature for which she was eager to sincerely add to. And it is students like Sirena who make it a delightful and humbling experience to teach, to mentor, and to work with young emerging artists. So please join me in welcoming Sirena Pearl.
Hi everyone, thank you. I want to thank everyone for coming to our opening reception for our mural project on the urban heat island effect. At this end of the presentation, I'll run a Q&A if any of you wants to ask questions about the mural or the research project. But to explain my mural, I want to first talk about the urban heat island effect. An urban heat island is an urban area having a disproportionate ratio of heat-absorbent infrastructure, such as asphalt and concrete, to its cooler counterparts, forest coverage, and vegetation. My favorite analogy to picture the urban heat island effect on a small scale is to think about the surfaces we walk on in the summer. If we were barefoot, I think many of us would choose to walk on the cool grass rather than the burning hot pavement surface. This is because pavement absorbs heat much faster than a grass lawn. On a small scale, this analogy is what contributes to the urban heat island effect. July 2023 was reported as the hottest month in global history since 1880, according to NASA. With increasing temperatures influenced by anthropocentric climate change, the urban heat island effect is becoming more prominent of an issue than ever. Often, like many of other environmental issues, redlined neighborhoods bear the worst of these effects. This is a map from an article by the New York Times that shows the disproportionate temperature differences formerly redlined neighborhoods in Richmond face during the extreme heat waves in the summer. Decades of racist housing policies have given these communities the least amount of access to temperature cooling infrastructure and vegetation, causing these communities to bear the worst of temperatures in the city. With the help and support of VCU's undergraduate creative research fellowship and VCU Arts, I created a project to measure and communicate the effects of the urban heat island. My project research used a thermal infrared camera to measure the thermal qualities of the paint. I purposely painted with these properties to create temperature contrast in the mural to visually communicate the thermal differences of the two cities personified as figures. The two figures are contrasting, but their limbs interlock in a pulsing configuration, representing the complex and chaotic ecological systems of the humans and the environment. The red figure personifies an urban heat island. The figure is sweating and is in pain from absorbed heat. The surrounding environment of the red figure displays concrete infrastructure, asphalted roads, and empty vegetation. The blue figure resembles a city modeled on sustainable foundations, with extensive forest coverage, wildlife, and infrastructure rooted on garden roofs. The blue figure's temperature is cooled, and their posture is mostly at rest. However, their pulsing limbs interlock with the heat island as a metaphor that the environmental system is complex and may change over time. A surprising coincidence that I noticed while painting this mural was how the surrounding landscape of Richmond aligns with the design cities of this mural. I could see the forest city divide of the design align almost perfectly on the division of Richmond's vegetation and city half. This comparison was most apparent when we flew the drone over the parking deck right above the mural. I captured a still of the drone's footage and blew up the images of the divided landscape of Richmond City. On the left, we see the vegetation, and on the right shows the city infrastructure. In the next few slides, I'm going to share the thermal infrared images I took of the mural, specifically the images displaying the temperature contrast I found using different tonal shades of paint. My main objective was to create these temperature contrasts between the two central figures. My goal was to highlight the cooler thermal difference in the blue figure representing a sustainable city against its heat island counterpart. To do this, I used the iron bow color palette in the camera setting. The iron bow color palette represents the whitest yellows as the hottest temperatures and the darkest purples as the coolest temperatures. In this comparison, we can see the red figure absorbing more heat with its yellow and white color palette and thermal capture. The images taken with the thermal infrared camera confirmed our hypothesis. The darker shades of paint absorbed a significantly greater amount of heat than the lighter shades. Again, this is shown with the black paint representing the yellows of the iron bow palette, and the lighter blue windows displaying a cooler purple shade in the thermal infrared capture. While taking these thermal infrared photos, I was most excited by the amount of image clarity one could see with the temperature differences. Here is one last image showing the thermal contrast apparent with the tonal values of the mural. More of these captures will be available in the link attached to the QR code at the end of this presentation. The other thermal technique I measured was painting with a clear solar reflective coating. The solar reflective coat I applied was a clear satin cool coat. Its formula contains tiny ceramic spheres, which helps the painted surface reflect the sun's ray and cool its surface temperature. Often, solar reflective paints are applied to buildings and pavement surfaces to reduce the amount of absorbed heat in urban areas. This is just one of the many solutions that can be used to reduce the urban heat island effect. Here are the before and after images of testing the solar reflective paint. The second photo on the right was taken after applying the coat. The second photo was taken on a slightly hotter day than the first capture, which is on the left. However, despite the hotter outdoor temperature, the mural's surface temperature was 9.1 degrees cooler with the solar reflective coating. A reason I created this mural was to make this type of data more visual and accessible for a wider audience. Because if we only looked at quantitative data, we would be greatly limiting the population to spread this message to. We can also see a temperature difference using the solar reflective coating in the thermal infrared captures of the flowers, with a 5-degree temperature drop in the surface temperature. I want to thank everyone who donated through our GoFundMe for helping make this project possible. With our donors' help, Roberto and I were able to rent scaffolding, purchase paints, and the solar reflective coating necessary to make this mural. I also want to thank Dr. Stephen Fong, who generously let us borrow his thermal infrared camera for this project. I want to thank Jody Samula for her tremendous help with our project proposal to VCU's Art on Campus Committee. Another person I want to thank is Ian Hess. Ian greatly helped us learn about the logistics and materials of mural painting. If you don't already know Ian, he's an artist and VCU Arts alum who owns the mural and art supply store, Supply. And this is his Instagram. And then I also want to give a special thanks to my mentor, Roberto Jamora, because from the very beginning, he deeply invested in the success of this project, and I couldn't have done it without him. So I would like to now open the Q&A if anyone has questions about the mural or the research project.
What was the process in the choosing
Yeah, so some of the biggest factors in choosing our location was to see which walls had the greatest access to the sun, because we wanted the sun to be able to have the longest exposure to the mural for the infrared testing. And ideally, our wall was perfect because on Bow Street, the sun hit the wall right in the afternoon during the peak temperatures. So we were able to see the greatest temperature difference with how our wall was facing. And then another factor was like the size. We wanted to have a big enough scale so you can see the thermal temperature differences in the mural.
Did you take, before you did the mural, did you take before temperatures prior to starting the project?
Yes, so, well actually, we did not take before temperature differences, but we had temperature differences of the city, which is the urban heat island, which we didn't put the solar reflective coating on. So that worked as our control.
Right.
And then the areas that we applied the most of the solar reflective coating was the sustainable city side, where I coated it all with one layer, and then areas like the flowers and the figure were coated with multiple layers to see kind of how the clear coat worked. And I think the figure had the most, the sustainable figure had the most layers, which was like around 3 layers. Hi.
Beautiful, incredible work here. How did the summer heat affect your process of making the mural?
Yeah, that was probably one of the hardest parts about making the mural. It was extremely hot. We started, I believe, we got the site beginning of June, but we started mid-June when we were able to finally set up the scaffolding. And it lasted till July 28th. So it was very hot. I had to wake up at 4 a.m. and go before sunset to avoid the heat. And often, like, I stopped painting around 12 p.m. because it just got too hot and humid. And again, that's when the sun started hitting the wall.
So is that, so it's, you were saying that it's commercially available, this protective sealant, is it clear protective sealant?
Yes, they also have like actual paints that you can get, like solar reflective paints. We were originally going to do that, but when we found that there was a clear solar reflective paint, we thought that would work best, so we wouldn't have to like repaint all the work that had already been done. So when my stepdad Eric, he found it, we were like, oh, that works perfectly. So we just had to like coat it with the clear solar reflective coat. All right, we have time for one more question. But you guys, oh, hi.
Hi, Sirena. So the scope and size of this canvas is pretty large. So I'm really curious about like your planning of like actually scaling up to that size.
Yeah.
And were there any points or times where you felt like, oh, I have to pivot my what I thought was going to work is not working. Let me figure this out and maybe rethink what you're doing.
Yeah, that's a really good question. We, I think the hardest part when we first got the site was measuring it, because I remember this was before we got like the full scaffolding set up, so we were having a really hard time getting the height of the mural. I remember I tried to use a tape measure, but it kept flopping down when I tried to measure the height of it. But actually, I work at VCU Library Workshops, and I was talking to my boss about it, and he told me that there's these laser pointers which you can like measure the distance if you use the laser point. So when I used that, I was like, oh my gosh, that makes such a easier plan. So I think that was the hardest part, because once we finally got the dimensions, I was able to grid it out, and that was very labor intensive. But luckily the grid did in the end work with the design. So I think the hardest part was just measuring the site to begin with. I remember it took about a week to figure out how to do that. Yes. Preferably, I'm gonna try to do it in the springtime or the fall time. But yeah, definitely. All right. Oh, hi, Joy.
I think Chris's question is good. So what's next? Is it a mural? What's next for you?
Well, right now I have some pieces that are going to Qatar that are through VCU's Art Foundation program. I believe it's in November. Is it November? Yeah. So right now I'm mailing those off, but yeah, I'm doing my painting and printmaking classes and just trying to build up my good portfolio of oil paintings.